And I am Adam Decker.
And this is our team presentation for lesson 1-4.
A medieval harvest festival is a text-based role-playing game. In this game, you will have to find evidence to find out where the princess was taken and who kidnapped her.
When creating our programs, we use high-level design. We specifically based our programs after the MVC pattern, which stands for Model, View, and Control. By using high-level design, we are able to organize our programs and separate the input, processing, and output functionality of our programs.
This is the model layer. The model layer is responsible for containing the classes that the data objects are stored in for a program. These classes in the model layer are representative for the logical and physical things in a program that contain data. The data diagram in this slide shows a few of our object classes. At the top of the individual boxes is the name of the object class. So the top left box represents the player object class. Directly underneath the class object name is the attributes. The attributes are what define an object's qualities.
An example of an attribute of the player class object is the name, which describes the name of the player. Beneath the attributes are the functions of the class object. The functions usually get or set the attributes of the class object. For example, the function setName would be able to change the attribute name of the player. Attributes of class objects have a minus next to them that represent that they cannot be directly set or received. Attributes can only be retrieved and set by the getter and setter functions of the class object. The plus represents other instances are available to use these functions. Notice the lines between the boxes. These lines represent relationships between the class objects.
The relationship between player and game is an association relationship. The one represents one player. The one ... asterisk represents many games. One player can have many games, or many games can have one player. The other relationship partially shown in this diagram is a composition represented by the filled diamond underneath map. This means that the object is contained logically in the object and cannot exist out of the container, such as the object map containing the object location. But location cannot exist separately out of the map.
This is the control layer. The control layer is responsible for the actions that control the behavior of our programs. This includes all the functions or commands that are executed as a result of an action taken by the end user, described in the end user story. Class objects in the control layer contain functions that can use and modify data in the model class objects and perform calculations and decisions. Class objects in the control layer only contain functions, which are all public. They use the attributes of the model class objects through getter functions. In the UML diagram in this slide, we can see the control class object consumable control. We use data contained in food item and beverage item to perform a calculation to determine how much a player would be filled by consuming either class of item. The relationship between consumable control and the two consumable items is called a dependency. A dependency is when an object uses another object but does not own or contain that object. This relationship is indicated by the dashed arrow and the keyword uses.
The view layer is made up of the classes that are responsible for the end user interface of the program. This can be compared to the Earth's surface. We all live and interact above the surface, and in most cases we cannot see past the surface, although we know that there is more going on and more to the world beneath us. To be more specific, the view layer retrieves the input from the end user, processes the user's request, and displays output back to the end user.
To implement Java Beans into the model layer class objects, we implemented the serializable interface, created default constructors, and we gave the class object attributes with private modifiers with public getter and setter functions. While it is not required, we also implemented the toString, equals, and hash code ToString is useful because it can be used to print out the values of class instant variables in a string. Equals is useful for comparing values of instant variables in one object to instant variables of another object in the same class. Hashcode is useful because it speeds up sorting and searching for objects in a collection.
We simply implemented the serializable interface by adding the keywords implement serializable after the name of the class object. This allows the data stored in class instance variables to be translated into a format that can be stored on a disk or transferred over the network.
To create a default constructor, we right-click our programming screen and select Insert Code. We then select the constructor. In the next window that pops up, we do not check any of the boxes. The default constructor is used to create a new object instance for our classes. We also add ToString, equals, and hashcode by right-clicking and selecting Insert Code.
We simply make our attributes in an object private. This encapsulates the data. We then add getters and setters for these attributes by right-clicking and selecting Insert Code. The getters and setters allow our attributes to be modified and received.
For our programs, we first had to define our problem. We did this early on when we wrote our end-user stories.
Design is decided by what means we are solving the problem. We have done this by mapping out our object classes of the model and control layers on UML diagrams. We also did this when we created how the end-user interface will look in the end-user stories. We also used design in creating the test matrices for our control functions.
We are constantly developing, testing, and deploying our program. We have created the model and control classes so far, and we have also created tests for our control functions. We have been able to test our control and model layers using the tests that define the results we expected. We have to deploy our code constantly to the remote repository in order for us to be able to collaborate on our project.
There are 4 primitive data types.
Integer data types are used to store whole numbers.
Float data types are used for storing decimal numbers and whole numbers beyond the long integer data type.
Boolean data type is used when you need a variable to store either a true or false logical value.
Character data types are used to store Unicode characters.
Arithmetic operators are used to perform simple arithmetic, such as addition, subtraction, and multiplication.
Relational operators are used to compare 2 expressions or values, resulting in a true or false.
Logical operators are used to make Boolean comparisons between 2 expressions that evaluate to a true or false Boolean value.
Bitwise operators are used to change and compare the individual bits of data.
We call functions using instance containing the function followed by the function name, then followed by the arguments contained in the parentheses that follow the same order as defined by the function's parameters. The code in this slide is a snippet from a control test. We are making the double result equal to the result of the function. We call the function calculate volume of pool to the instance 2 and pass the variables pool width, pool length, and pool depth to calculate the volume of the pool's parameters. These variables are used to calculate the volume of the pool.
Variables that can be used have to be called either directly within the block they have been called from, such as a variable declared in an if statement being called by the if statement, or directly outside the place the variable was being called from, such as an if statement calling a variable that was declared in the class itself. In the code taken from our program, the variable hash declared in hashcode function can be called within hashcode. The variable quench factor was called in hashcode, and it was able to be called because it was created directly outside hashcode.
Okay, that's all for now.
See you next time.